As we said, I'm going to try to do some live hacking demos, which we all know how easy that is, over Wi-Fi and over VPN. So let's see how this session goes. I just want to start out with, there has been a lot of talk about AI, and I know it's like I'm quite tired of AI, but I also sort of like to apply it and see what we can do with it. And when I got accepted for this talk, which was like a couple of months ago, then I had some tools and I could run them with AI and everything worked great. And then in this space, quite a lot of things happens very quickly. So if you go to sleep, something new happens. So this project, which started out as a really, really small like proof of concept, yes, we can automate hacking with local language models, turned into something. I can't release this open source because it's so old and so dated. So a couple of weeks ago, I realized I'm going to present this. So now I need to start rewriting everything with this new thing called MCP, which just happened a couple of months ago. I was like, I'm a hacker. How hard can it be? You just type some MCP stuff and it should work, right? No. It's a very new standard and it's not standardized. So how hard can it be? Anyway, what I'm trying to present is an MCP server where I integrate hacking tools. Because how many of you are pen testers here? Raise a hand that you work daily with pen testing. Okay, so maybe a fourth of the audience. What I learned mostly doing this is how broken the actual tool chains are. But we'll come to that later. A bit about myself. I'm very old. I started hacking before when I started uni. It wasn't called pen testing then, it was just called hacking. There was no such thing as pen tests. So I started so I've been working with this for as long as I've known, basically. And I also worked with AI since long before it was called AI. It was called just ML back then. And we did have it in uni, and then we could run like neural networks. We could simulate 3 neurons. That was what you could do back in those days. So I've always been fascinated about the AI and the ML and how to apply it in actual tasks. So applied ML and AI. I'm also, for what I do for a living, which is not this, is that I am the CTO of FIO, and we do code audits of highly critical infra systems and a lot of Web3. So all the layer ones, if you transferred some Bitcoins, well, actually not Bitcoin, but all the other ones, we work with all the layer ones and we audit the core infra code there. And we do OSINT monitoring, anti-phishing, and all this like cybersecurity stuff. So let me ask you a question. Can you guess what's the worst thing that you have to do when you're doing pen testing? Anyone? Report, yes. This second next worst thing with doing a pen test. Waiting for Nmap. Nmap is like broken. That's what I realized when I was doing this again. It's like, I've been away from this like pen testing for like 10, 15 years, and Nmap is now possibly even more broken than when I left 15 years ago. It's now, it can't even count anymore. It's worse than an LM in counting. It's like, yeah, I estimated we're done in 3 minutes. We have 15 minutes running. I estimate that we're done in 1 minute. It's now been 25 minutes. So basically, the tool chains are broken. So I thought to myself, let's apply some AI agents. And AI agents is the hype. The year 2025 has been dubbed the year of the agents. And if you believe all the hype, they can solve all your problems automatically with LLMs. So the definition is autonomous AI systems that can perform tasks autonomously. Let me tell you, we're not there yet. You don't need to be worried about losing your job, at least not to these frameworks that we have today. But they can execute complex workflows, make decisions based on context, use tools, or nowadays they can sort of use tools. We'll see that in the demos. And ideally collaborate with each other and humans. So my takeaway on agents after having done this research is it's a glorified for loop. If someone tries to sell you an agentic framework, what an agentic framework really is a glorified for loop. The LLM does it wrong, do it again. The LLM does it wrong, do it again. Change your parameters, do it again. Ah, you got it right. We have a super smart LLM AI tool chain that will solve all your problems. So that's in reality what the agents are. So that made me, and we're going to see this in the demos. Not all the demos are going to work. They work sometimes because LLMs and for loops are going to do interesting stuff. The good thing is that we now have at least an idea. All of these frameworks work basically the same way. We have a user query where we type in. We have an agent that ideally nowadays can do reasoning, sort of. And then this is the new thing with MCP. I said this is going to be an MCP server. So I've written this using this new standard, which is MCP, where it can select tools, it can execute the tools, it can do observation, and then this for loop just keeps running until it has something to report back to you. So I thought this is a good test to do for pen testing, because this is basically what a pen tester do, right? We do a tool, we find some host, we observe, we have some open ports, we run vulnerabilities there, we do this over and over and over and over again, which is quite boring, and we have to wait for Nmap, so we hit enter and see how far we have come in our scan, and see if we have any interesting ports. So that's where I thought, like, let's automate this. So what I built is basically a red team MCP server that implements an MCP server for any agentic framework, because you know my view on agentic frameworks right now, so I'm not going to spend any more time writing agents in this project. But I do think what will be valuable, and I'm releasing this open source at the end of this presentation, is the actual MCP server, which you guys can all use with your agentic for loop of your choice to run the tools. So the idea when I designed this is to have agents that can interact with agents and have a common truth source. So there is a database in this as well. So let's talk about MCP. When I learned about MCP, I was like, oh no, someone again that's going to come up with a stupid standard for something like a Docker container, which is just going to add stuff and fluff around my for loops. But then I started realizing this is actually quite good. And really what it is a standard for any AI model to interact with any tools and services. It enables access to any external tools, execute commands, process results, make decisions, and basically, how many of you have used these like automated vibe coding tools like Cursor and all of this? 1, 2, 3, 4, 5. So basically what that is an MCP tool running with user privileges on your machine, calling from an external LLM that executes commands on your machine through an MCP server. So an MCP server can go both ways. There are so many security implications of this. Can you guess what the supported authentication patterns in MCP is, for instance? None! Or actually now, there's a pull request last week for implementing OAuth authentication in an MCP server, but none of the agentic frameworks yet support it. So the security implications of running these Cursor and all this, I tried all of them. Actually, this presentation, isn't it nice? It's totally vibe coded. I haven't written a single line myself. It's just someone has ripped up the CSS. I just asked it, like, do a hackerish background with bright colors and blinking cursors, and I got this. Quite good. So the security implications are bad for MCP, but it's also, it's a glorified REST API, but it supports streaming because we as human thinks that things work faster if we get the results streaming. The LLMs aren't faster, but we perceive them as faster. So it's basically a standardized communication protocol. It can run as a server, or more commonly loaded as like standard I/O pipe on your computer. So basically in Python, this is really simple. So all we have to do is like do your favorite port scanning tool, where I, of course, started with Nmap before I realized it's totally broken. So you just mark it like MCP tool, and then it will be exported for all agents in the world to communicate with. And we just await this command, and it runs on our server. So I thought, this is really cool. Then we just wrap Nmap, a vulnerability scanner, and Metasploit, and then we're off to the races, right? Sort of. So what I built was this. What do you need for a minimalistic, automated pen test? Well, we need a port scanner, we need a vulnerability scanner, we need SSH access to make sure that we can actually log on to the boxes. We need some sort of way to run exploits, Metasploit, and ideally we need to do some discovery modules as well to see what host we have. And most importantly, we need somewhere to store this. I chose MongoDB to actually store the results. And I also wanted this, since what we talked about is red teaming. So we need to actually be more than one person that can interact with the toolchain. Otherwise, it's not red teaming. Otherwise, it's glorified single pen testing. So we need a database where we can store all the information so far that the agents can keep on working on the information that we already gathered. So is it red teaming? No, not really. It's not very stealth. It doesn't have very good discoverability. I just send off all the ports at once, so it's more of a proof of concept. But it can be used collaboratively for pen testing, where you can work together, both agents and humans, from the same truth source. And hopefully do so the teaming work of red teaming works, if that makes sense. As we said, we started with the port scanner. I started with our favorite Nmap, and I realized it doesn't support JSON output. It's like, guys, this is 2025. How can you not support JSON output? What am I going to do? It's like, no, you need to do export to XML and then convert the XML to JSON and then parse the JSON and input it in. It's like, no. So in the end, I choose masscan instead as the port scanner for this module. And it just works. And you put like -J and you get a single JSON line asynchronously per detected port. Perfect. Vulnerability scanners. I thought, when I was a kid, we used to run Nessus. Nessus is also broken. It's super broken. It's more broken than Nmap. So this is my key takeaways. How do you guys do it that still does pen test every day? It's like, how can you live with this tool chain, a box of tools where like, oh yeah, this hammer's broken and this is broken, but we just tape it here with a Python script? It's like, I think really we need some sort of MCP protocol for hacking tools. I would love an MCP protocol like HCP, hacking control protocol, which all tools talk the same way, so we can actually chain them together and pipe them to each other. That might be the better way to spend your time than doing what I did. So SSH was fairly simple. There's only one SSH client. And then we had Metasploit. That also is very broken. Have you tried searching how long does it take to search for all the vulnerabilities when you have them on disk? So there I had to build like a tool that indexed everything and put in a database. We know what exploits we have. So anyway, the workflow for working with this tool is we have a discovery phase. Might actually do a demo of this. So can we resolve all subdomains for gofio.com? And hopefully now this works. Well, maybe not. Might have to restart something. or actually starting a discovery. And I just want you to know that everything that I'm doing here is running on local models on this Mac Mini. I tried to do this because my MacBook here only have 18 gigs of RAM, and I tried to run this on another demo a couple of weeks ago, and it took forever because I had my dev environment open, so I didn't have enough RAM to do that. So it literally took forever. Yeah, okay. My DNS is not working over my VPN. So, but anyway, this is what it does, the tool. We'll get back to the demos, and hopefully they will resolve this. I might have to restart my VPN connection to get DNS. That would probably help. So exploitation, we're leveraging Metasploit, which we indexed. And then post-exploitation, the agents can use SSH to actually see that it's got access. And reporting, all the results are stored in a database. We can just generate reports. So the port scanner, we decided to use, or I decided to use mass-scan instead. Banner grabbing is broken in mass-scan, so I had to write my own banner grabbing function. So there was a lot of more writing code in this than I thought. I thought I would just take tools, work together. And for the vulnerability scanner module, I chose to use nuclei, which is template-based. And that was a good choice, because when I started these demos this morning, I was like, I just put up, the demos should be the easy part, right? You put up a vulnerable host, and then you run the tools against it. Because I run this at 2 pentests, and it works really good in a real environment. But then it's like setting up the vulnerable environment was actually harder than I thought. Set up a vulnerable environment, did nuclei detect it? With like, no, of course not. You had to rewrite all the templates. You literally have to rewrite all the detection templates for them to actually detect the vulnerabilities. So that tool is also broken. So that's my big takeaway of this. Everything is broken, not in a good way. So it should have a comprehensive vuln database, but you need to actually verify that they actually detect detailed findings with references. And I've worked a lot in the ML and AI world in the last couple of years. And there is like, do you know what they have? They have like leaderboards on detection rate. How many of these things does this LLM solve? I would like to see that for Nmap. I would like to see that for Nucleo, for vulnerability scanner. How many of these like known hosts does the tools actually detect? So you as a client or as a pen tester can actually choose, okay, I'm probably going to use the tools that actually detect stuff. That'd be great. SSH, we don't need to talk very much about. Metasploit integration, we can connect to Metasploit and actually run the exploits based on what we found from the vulnerability scan. So there I had to do a sort of quick search to actually search and implement the CV search. So that's also done in Mongo. So there is a script you can just run that index everything that you have in Metasploit into a searchable MongoDB, which you can actually find. And then you can automatically run exploit executions through the LLMs. So ideally, the LLM should be able to first find a host, find open ports, run vulnerability scanner, run exploits, and give you a shell. We'll see if that works. I think I need to restart my VPN for that. But anyway, we can real-time query the Metasploit servers. So one of the things when I designed this as well was to do, I worked quite a lot doing it async. So basically, might as well do a demo of this. So we can start resolving a subdomain, but then we can look at tasks, because we want to do multiple things when we do port scanning. So we have a few completed tasks. Now we're doing a DNS lookup, which fails. So then we can do a vuln discovery for 10.0.0.2.2.4 on port 8080. So you can start with that, and what you're seeing here is the logs from the MCP server. So it's now starting the vulnerabilities. So if we do tasks again, tasks, you can see there are now 2 running tasks, and I can still ask the AI, why is the sky blue, hopefully. And it should not be blocked by that, ideally. So these tasks will now run in parallel, and I think the reason why this is going so slowly is my DNS has stopped working for some reason. It's always DNS. So now the tasks start responding. So if we do tasks again, we see that we still have 2 running tasks. And the task will return. So this way we can work multiple agents against the same MCP server asynchronously, and we can also connect multiple red team members doing this. So now it figured out why the sky is blue. Thank you very much. Sunlight is a spectrum of light, so we still, ray light scattering. It figured that out eventually. And we'll see eventually if it figures out if we have any ports open. And as you see, we're still in the background doing a port scan of the entire network. So we can work as you normally do on a pen test with actually running all these like tools together. At least that's the idea. So another cool thing with the for loops is you can have an agent, which is an LLM that runs a for loop. You can have one for loop, which is like the big agent, and then you can have like a hacking agent that's specialized in Unix, which has slightly different prompts. Then the number 1 agent can call this agent, and it's like, hey, Linux hacking guy, can you hack this box for me? And it will have the same tools, it will do stuff slightly differently, and when it's done, report back, and it's like, hey boss, it's vulnerable. So you can have like different agents for different stuff. And that's one thing I learned as well, because if you're writing a large number of tools, it's better to have a virtual team, actually. One that's specialized on Linux, one that's specialized on databases, one that's specialized on reporting, because otherwise they tend to get for loop very confused if you have too many options. They're like, ooh, I'm actually, they go off on a tangent, they start doing something there, and they never finish the core tasks. So you have to have multiple for loops. So you can actually have one agent calling another agent as a tool. So we have like hack machine, and that hack machine will actually call another agent which is specialized with specialized prompt to hack machines. So let's try that. Can we hack 10.0.0? What was it, 224? On port 8080. Let's see what it does. So it's starting penetration test, calling some banner grabbers, searching what findings we already have. It's calling enumerate vulnerabilities. And then we'll see, it might actually start exploiting at some point. So the database structure is we have like scans where we have all the ports, we have a findings, and we have a collection for exploits which you know, so we can actually, or the AI agents can search for which exploits match the ports. And then we have a unified search across all findings, and we can share this knowledge between all agents, so they can start with like, okay, what findings do I have already, and what can I use to exploit them? And basically, this is how I envision it. It's like a bunch of really bad toasters with a single for loop running locally, and this is currently my toaster. And the reason why we tend to call them toasters is that they get really, really warm doing this because they spend a lot of power. You can probably toast on the bigger ones. But the interesting thing with running local models, when I started if someone would have told me like 12 months ago that I could run 32 billion parameter models locally, I would say, nah. So what's happened is that we have actually had 10x in performance through some optimization and research, and I must say quite a lot thanks to the Chinese, because they couldn't buy enough NVIDIA hardware, and they wanted to win the AI race, so they optimized the crap out of their models. So the models I'm running now is Qwen 3, and the Qwen models are at least 5 times more information dense than any previous models. And then we had quantization. That means that you can get them down. A couple of years ago, it started in 32 bits. Now we're running them in 4 bits to fit them there. But I still get better performance than a smaller model in 16-bit. And also, the prices of running these models, this Mac Mini costs like 500 or $1,000. So we have a 100-time price drop in the last 18 months of running models locally. So there is now no reason they should call an API provider on an AI and give all your hacking data to a third party. There is like, literally, go buy a Mac, you can run everything locally. Or a Windows laptop with an NVIDIA chip, like the 5090. There is 5090 laptops, I'd love to have one. Why agents are changing everything? Well, I think everyone that's worked with pen testing have been writing scripts to cobble tools together. This is just what this is, but it's a unified API to cobble things together, which is called MCP. And it makes total sense, because we can do stuff in parallel. And currently, this poor guy is like, okay, I couldn't find an exploit, so now I'm trying SSH, and it's like, I mean, as you see, they're not super smart, but I haven't given them like which passwords to try. I haven't told them. It's like, get a bloody shell on this machine. These are your tools. And then we'll like run and run until it gets a shell, or eventually we'll go, I was like, sorry, my length is full. I have no more things I want to try. Here, calling exploit. Why is it running Roxy VIX? I don't know. But it's actually finding vulnerabilities. Here it's thinking. It's finding vulnerabilities on the system. It's running exploits, not the right exploits this time. So that's why I'm saying you don't need to lose. You're just like, oh, I'm gonna lose my job as a pen tester like tomorrow because AI is gonna take over. No, that's not the thing. But can you work together with AI? Like what exploits? Oh, now it's actually saving the hacking results to the database. That's probably good. Do we have against Drupal, which I know we have a vulnerable Drupal server. So hopefully it's now going to search that. So ideally, we can put up, we can automate the boring stuff. And the agents can, if you write the right tools and the right prompts, you can actually quite easily get them to test everything. So we can focus on more high-value targets. And they are quite good at identifying patterns and like figuring out easy stuff like, okay, if we have this banner, we should probably try all of these exploits. Okay, this exploit sort of worked, but it didn't with this payload, so let's test all the payloads. So they're quite good at doing this tedious part of pen testing. What they're not good at is like focusing, even if you have prompts that tells them to focus, they're not really good to this. So they can work together as a team, but they need guidance. It's the same thing with everyone that says like AI is going to take my job. I think our job as a pen tester is going to be still a pen tester, but we're going to use these tools. Instead of using Nmap, we're going to use agents that use Nmap, but we need to orchestrate them together to go after the right thing so it doesn't go off on a tangent and start attacking a printer in the corner that no one is interested in. And this is always going to be the thing with automation. And they're not very smart, and it's like having a bunch of kids running around trying to do stuff, right? So you have to still guide the kids in the right way because they're never doing exactly the right thing. So I think that's the AI takeaway with agents, that it's the same thing with self-driving cars, right? We said like 10, 15 years ago, oh, well, tomorrow we're going to have self-driving cars. Look, the Tesla can change lanes and it's going to be great. And all the truck drivers are going to go out of a job. They're never going to have a job anymore. Same thing with AI agents this year. It's like, oh, everyone's going to be out of a job. All coders, go away. You're not going to be able to write code. Trust me, I've been vibe coding now for a couple of weeks or months. The code it generates currently is terrible. We're never going to be out of a job. There are so many security vulnerabilities. There is now like, did you know that the commit frequency on GitHub has doubled this year? So that means there's double the lines of code being committed than last year. And all of that's AI generated, or half of it's AI generated crap. So basically, I'm open sourcing this right now. I'll make the repo public right now, so you can just install the dependencies, Mongo, Nuclei, Masscan, Metasploit, set up a database, and run the server. And that's not my username. So it's on my GitHub, which is Skjortan23, Skjortn23. And the documentation is not there. That's also AI generated. That's what I'm saying. Like, don't trust an AI to write your presentation for you, not even the closing slide. So let's see. So it actually found that it has a summary of findings. On port 8080, we have a Drupal, which is vulnerable for CV 2018-7000, critical. Drupal Geddon, exploit details. So it actually managed to hack a box against Drupal, which is good, I guess. Can we run the Drupal exploit again against T000-224 port 8080. Let's see if it runs this right exploit. It might have been forgotten. Boom, it's running the exploit. Waiting for session to connect. Checking result true. And I think I won't get the shell back. I did remotely before. But we have a VPN routing problem, and now I need to reach my vulnerable host over VPN, so I'm not getting the shell back. But it actually has found, it's run the scanner, it's run the port scanner, it run the vulnerability scanner, and run the exploit against the box. Great. Can we do a report on what we discovered? And hopefully we get a sort of pen testing report. Obviously, these prompts can be refined and defined better. So I'm open sourcing the agents as well, but the agents are more a way of like demoing in this scenario what you can use the tools for. Obviously, you need to write this better. But what I want to release and what is actually working quite well is the MCP server, which has all the tools for your agents to do automated pen testing. So that's probably what I would like to leave you with. I'm not sure, we still have time, I think, so let's open the floor to questions. This is the first time I run this presentation, and actually went a bit quicker than I expected. I only rambled a bit. Any questions?
Do we have a runner with a microphone if there are any questions? Not seeing any hands at the moment. But I have a question, actually.
Okay, yeah.
So how difficult was it vibe coding the server to actually interact with all these tools? Like, for example, if I sat down and wanted to add a new integration with something else, how much work is it?
If you don't, I spent quite a lot of time getting everything to be async, so you could do multiple things at once. And that's actually, the vibe coding tools are not great at like async. AIs are lazy. They just want to do the quickest way possible and just hard code in a lot of stuff and gives you a bunch of code. It's like, ooh, but I know this. It would have been quicker for me to not vibe code this and actually write all the code correct and short and nice from the beginning, because all the modules that I vibe coded, I had to go back and it's like, what have you done? What's this? You can't like hard code the FTP version into the. It's like, no. So I had to rewrite most of the code that was vibe coded, and I tried all of the vibe coding for Augment. I tested Augment, I tested Copilot, I tested Windsurf, so I tested all of them, and they're all equally bad. So I think me as a security auditor, code auditor, I don't think I would be out of a job, that's for sure.
Right. Well, I mean, it's we have another question over here, I think.
Yes. Yeah. I noticed that you wrote thank you, and we all know that ChatGPT is spending millions on people saying thank you. And I noticed that you wrote rather politely to your AI. You didn't say thank you in the end, but you say thank you to us. Have you noticed a behavioral difference depending on how you write your queries?
Not the end user queries, but in system prompts, because what we need to remember is the system prompts always comes first. So you give them agents a system prompt. And there is actually a lot of research on I thought when we started this like road to AI that the idea of having a prompt engineer was like, oh my God, that's not engineering. But there is now prompt engineers that are measuring how biased prompts and positive, if you give them positive feedback or negative feedback, will improve the quality of the output of the LLM for sure. So that's definitely a thing. Right now, the consensus is it doesn't matter if you give them positive or negative reinforcement, but giving it either positive or negative reinforcement will improve the quality of the output. So you can say, you're a great pen tester, you're the best pen tester in the world, and you love getting a prompt. Or you can threaten it, like if you don't get the prompt on the systems, your kids won't have food on the table. It doesn't matter. But any of those two biases will give better results. That's proven, which is funny.
Thank you.
Do we have anyone else? Doesn't look like it. All right, thank you so much.
Thank you.
And